Hello and welcome everybody. My name is Corey Lambertson. I am the General Manager of Americas for Asiga. And I would like to thank you all for attending our webinar today. And so our webinar today, we are going to be discussing the advanced functional industrial material solutions from Henkel Loctite for printing on the Asiga line of 3D printers. And so this is going to be a very informative presentation on what materials are available and taking a look at how you can unlock some applications with our 3D printer lineup, combining it with the Henkel Loctite resins. And so before we actually get started, just a couple of housekeeping duties. This webinar is being recorded and it will be shared on YouTube at a later date. And so if you ever need to come back and watch it again, please feel free to do so, or feel free to share it with any of your colleagues or mentors that you feel should be taking a look at this material printer combination. Now, let's go ahead and do a quick introduction. So with us today, we have Hendrik and we have Vittorio, both from Henkel Loctite. Hey guys, how are you doing?
Yes, thank you. We are doing good for myself.
Hey everyone. Hey Corey. Yeah, we're doing good. Excited.
Very excited, yeah.
Very good, very good. So the Vittorio, where are you coming in from today? I know you're across the pond, I like to call it.
Yeah, very well. Thank you very much for inviting us. So I'm currently located in Munich, Bavaria, Germany. So I'm here in the early afternoon.
Awesome.
Yeah. And yeah, as said, my name is Hendrik. I'm lead application engineer. I'm usually based in Heidelberg, Germany, but currently I'm in Concord, California for the next 2 months. So for me, it's 7 a.m. in the morning, but we will do it.
Yeah, awesome. Well, thank you both for joining with us. Now, before we get started, I don't know if you guys can touch on maybe the history of Henkel Loctite and their material offerings and how you guys got started, why there was interest for you. Because, when I think of Henkel Loctite, I think of Loctite, I think of thread locker. I grew up as a kid, working on, whether it was working on a car with my dad or working on, anything else where we had Loctite, or I call it Loctite, but thread locker, it was always Loctite. And so that's, where I knew the brand from the most, and the adhesive line. But you guys also have a 3D printing line. Can you guys talk a little bit about that area?
Yeah, sure. So we will come to this actually in a minute in the presentation as well. I don't know if you want now an answer already in the presentation, but we are very famous coming from also a very strong B2C business, which is laundry and home care. And half of our revenue is coming from a B2B market, thanks to the acquisition of Loctite. As our resins and the nature of our products are focusing on B2B, as well as the nature of our product being very similar to adhesives. It was like a perfect fit to bring our, let's say, startup, because we are coming from acquisition, into, let's say, the Loctite business.
Awesome. Well, I guess I got a little excited and jumped the gun there. So I'll let you guys take it away. Vittorio and Hendrik, thank you again so much. We cannot wait to see what you have to present for us. And then at the end of the presentation, we do have just a small announcement from Asiga, so I'll share that. It's kind of exciting. And then we'll open up with Q&A. So if anybody has any questions, feel free to go ahead and just type them in and we'll answer them at the end.
Thank you very much, Corey, for setting this up and everything. Thank you very much. So my name is Vittorio Medolago. As I said, I'm a responsible business developer for Europe, for the DLP solution, let's say for the Loctite brand here in Europe. And just to give you a short guidance on what we are doing and from where we are coming, we are belonging to the Henkel Group, which is one of the DAX company, one of the 40 DAX company in Germany, which is doing a 20 billion revenue a year and has around 53,000 employees. It's important to know because also here we have a strong support and backup from a company and let's say a very professional organization within the B2B, which helps us a lot in the daily business. So we are coming basic from an acquisition 2017 in Concord in the Bay Area, very close to San Francisco, a company Molecule. And today we are somehow like a small startup within a very huge organization. So we try really to get the best out of both, being very flexible on a startup level, but on the other side also taking care and profiting from the support of the global organization, which actually Henkel is offering to us. Henkel might not be immediately a very famous brand, maybe to the people in America, but behind Henkel, we have, of course, a lot of brands which are very famous in the beauty care and laundry home care, very well known, like, for example, Schwarzkopf, Dial, Sios, Persil, Bref. So all the products where you're using the daily business. But most important is the B2B business for Henkel, which is, I would say, around 50% of the 20 billion revenue a year. And as I already mentioned, the Loctite brand and the 3D printing group belongs to the Loctite group, which is also coming from the technical perspective, and as also from the B2B perspective, as we are also have the possibility to cross-sell our product towards our adhesive customers for sure. So what is Henkel doing today, or Henkel with the Loctite brand in 3D printing? Historically, a lot of company might have seen that we have jumped into different 3D printing areas. We started with post-processing solution on the adhesive side. We were partly a reseller of company like HP. We developed materials for some companies, but at the end also find out and really focus that our core competencies is the world of photopolymer, because we are offering 1K components on acrylate base, and this is coming from our standard unit division, also very, very similar. So we make really use of the standard Henkel business production sites and everything. And today we as a Loctite 3D printing brand, if you ask us what we are doing 3D printing, really mainly our focus is supplying photopolymers and resins for the DLP technology mostly. And since just a couple of months ago, let's say Formnext last year, we also announced our first material for SLA. So we are just recently also entered in the arena of SLA. So today, as we are working very close with our ecosystem partner Asiga, we would like to give you an indication how we see the world of 3D printing and generally the hardware technology. Our perspective is that it's getting very complex. It's a complex technology on the resin side. It's getting very complex on the hardware side. We believe that the best way to offer a solution to a final end customer, on the right side you see the industrial end customers, the best way is really to offer it by leveraging the core competencies of companies. And our core competencies is to be a chemical company, to have an expertise in chemics. And the expert of Asiga is to be a very great company, hardware company in the field of DLP. And this is like really leveraging both the core competency and together offering a final solution to the end customer. And this is why, let's say, the synergy which we build by really leveraging the core competencies.
All right. Yeah, so I will take it over. Thanks, Vittorio. So let's jump into a little bit more detail. So into our materials. So first of all, what we usually do, we're clustering our materials into three big sections. Like we have our photoplastics. So within this section, we mostly have our rigid materials with special properties like high temperature resistancy or impact resistancy. Then we have our photoelastic materials with like low shore A, high shore A, high elongation, good rebound performance, and so on. And then we have the third section is resins for healthcare, so biocompatible resins. And jumping over to the next slide, you see our broad portfolio. Don't be scared. I don't really go into detail of all of these resins because I don't want to bore you with all of these properties, but it's just, this slide is really for giving you an overview on how diverse our portfolio currently is. So on the left side, our high impact resistance material. So within this section, we really have materials which are more like, for example, polypropylene-like or ABS-like. So with good elongation, high toughness, good impact resistancy. On the left corner on the bottom, we have the high temperature resistance material. So here we have materials of really high HDT. So those are with high strengths, and also like the 3955 certified through different sections. For example, the ULV0 certification, so flame retardancy and flame retardant. Then in the middle, acet elastomerics. Here are 4 resins currently. So we have on the right side our 402 and the 475. So the 402 has a higher tear strength, but also a higher Shore A. And the 475 is a little bit lower in the tear strength, but also softer. The 8195 is more a prototyping resin, and the 5015 is also very high in the Shore. So in the bottom, we have 2 resins for healthcare. These resins are what we call fully biocompatible. So this means we achieved like all of the sections from the 10993, the ISO standard for biocompatibility, and at least on the right side we have the pro materials. Like these are materials which are from an economical point, let's say, more attractive. These materials are not as that good in properties as our functional materials, but they are cheap and fast to print, very good for prototyping. So next slide, please. So what is very important, what we figured out, I mean, this is not really a secrecy, is like you have to control your process. If you want to have a constant result, if you want to get an application with big customers, big OEMs, you need to be repetitive in results. And for that, we created our workflow validation. So first of all, what is the workflow, or what is in the workflow included? So there is the material for sure, there is a printer, there is a cleaning device, and there is a curing device. But all of these several instances have a lot of data behind. Like for the materials, you have the product code, you have batch numbers, you have the version, you have the best before date. For the printer, you have your build styles, and behind that build styles are a lot of parameters. So a lot of operating conditions. The same for your cleaning device, like which model do you use and how old is the model, what cleaning fluid, is it IPA, is it a TPM based cleaner, and also the duration, or if you can also heat it up, for example, not in case of IPA for sure, but for TPM based cleaners. And the same as for curing devices. So which model, which wavelength, how long, how big is, how high is the intensity, and so on. And in between of these steps, there are also like parameters you have to track, like wait before time, before cleaning, like waiting till the resin or cleaning fluid evaporates, for example. So within this workflow, there are a lot of data, and also the format of this data can vary. So for example, you get a text file out of a printer, then you just wrote it down on your with your pen on a paper how long the cleaning process was, and then the curing device, for example, you're not getting any stuff at all. So you're also gonna write it down per hand. So there are a lot of data in different formats, and you have to you have to compile it. And this is what we're doing. And then we're coming to the validation, where we're really testing the physical properties, not only the physical ones, also like depending on the material, also like thermal properties or like elastomeric properties. And we then have like all this data like summarized in different formats. We have to consolidate, we have to track it. So how are we doing this? We're doing this with Albert. I will come to Albert like in 2 slides. Jumping over to the next slides, I just want to give an additional feature in for the medical section, because like the medical section is when it comes to validation is a little bit different, because on top of the standard validation like testing physical thermal properties, you also have to or we are also testing biocompatibility and extraction, meaning we're doing cytotoxicity testing external with partner labs which are accredited. We do sensitization, irritation testing like the 10993, 10 or 23. And this is just what I really wanted to highlight. And on the right side, we also have listed resins, not only the fully biocompatible resins, so also resins to support healthcare applications, what we call they're safe to touch. So there we did like basic biocompatible testing, meaning we tested cytotoxicity and irritation. So now we created a lot of data, we got a lot of reports and a lot of values, and these are, as said, floating somewhere. So we have to summarize them, we have to make them clean, and for that we're using a software called Albert. Albert is it's a data bank. So far so good, but it's a data bank with artificial intelligence and with a lot of tools included. So Albert was actually it was invented within Loctite 3D printing, and it's so successful that it's now spreading over the Henkel over the complete Henkel development side. So within adhesive, within laundry and beauty. So everyone is now using Albert, and there are several reasons why. So what can you do with Albert? You can, first of all, you can track your whole inventory, because as said, you have like the printer, you have the post-curing unit, and so on, and you can like create a digital duplicate. So we're putting like all these things as a digital duplicate into Albert. We're creating our whole inventory, including everything. Then we are tracking all these data, like the workflow, the whole workflow with all the data going into Albert, and that makes us possible to track like the complete workflow at any time, who did it, with which equipment, and so on. And it also enables us to be very smart in formulating, because Albert is learning. So whenever we created a formula, we created in Albert. Albert is learning. It takes like, we're putting a special formula in it, and they're coming out some mechanical properties, for example. And the next time we are maybe asking Albert for mechanical properties, and he gives us a basic formula. So it's very learning across the board. The third thing is tasks. Like, as you guys may know, we are within 3D printing are spread over the world. Like, I'm currently in Congo, but usually based in Germany. So we have our sites in California, in Germany, in Dublin, and to work together, like and formulate together and creating data together, we can create tasks, assign them to other people. So Albert really makes us work very efficient across the world. And yeah, the third thing said is the fourth thing, sorry, is the AI. Like it's intelligent, it's learning. Everything now is tracked in Albert. We can't think about having not Albert anymore. And this is also for a customer, for an application, it is very, very important, because this is our way to control the process when we come into validation. Like we track every single step, which means that our results are really repetitive. And when we are validating a workflow together with Asiga, for example, you can really be sure that the results coming out of this workflow meets the TDS. And this is really what Albert makes us allowed to be like completely trackable over the board with repetitive results over and over, and only if a workflow is validated, whereas stems from us, it goes out to the customer. So next slide, please.
Yeah, thank you very much, Hendrik, for giving us this insight about Albert. We are already currently now in a phase of commercializing Albert as a software. Maybe this might be interesting for our competitors. We want to give you an indication about the application currently, because we see a strong growth path for DLP, especially the last 4 quarters were very intense. I would also see this slide as not up to date, but I want to give also some indication in this webinar to give an idea for the Asiga users what could be interesting. So first of all, also because I have worked 7 years for other 3D printing technology as SLS, I want to give an idea about which kind of market segment this technology can achieve. So the nice thing is the speed of DLP, and the nice thing is, of course, the quality surface and accuracy. So for that, I would say in every market where you have a visible part, so is it interior, exterior parts, where people see interior or exterior is a visible part, let's say in a car, in a motorcycle or whatever, I would say this is a strong hint that DLP is the right choice for that kind of application. Another thing is, for example, connector is a huge business currently for DLP, and we see a lot of potential because you have the very thin wall thicknesses. You need a good surface finish, and for some of our material, we have also some quality assurance certification about, for example, UL94, and this helps a lot to enter in those segments. Of course, Hendrik also showed our high impact strength material. What does it mean? It does mean that it can be really used for high tough environments, like in the production side. So for example, the typically business also of other competitors is, I would say, jigs and fixtures, but he's a perfect fit because also you have like the perfect surface and the perfect accuracy. So whenever it comes to jigs and fixture, typically we recommend the 3172, the 38343. And the other materials which are more on the high temperature end are very interesting for tooling and low pressure molding as well as molds. So here we have, I will come to that soon, was a very interesting case study which we could finally publish. So we see a lot of traction, especially in DLP. Why is that? Also because of the surface finish. If you have molds, you have tooling, you need to have like an A value, surface value of 1 micron or even below. This is something which DLP can do out of the print. So without doing all the post-processing stuff, which a lot of company needs to do with grinding or whatever. So also take in mind, whenever you have a company which is in tooling, we have some very high temperature resins, resins, which has an HDT of 200 or even 300 degree. We have even one resin which has above 300 degrees HDTs, and this helps a lot to enter those markets. Interesting is also, of course, housings. It's also, I'd say, part of the visible thing. We had some very interesting cases. And what DLP can achieve, and let's say the resins is, of course, also clear materials. So if you want to have full transparent parts, We have the IND 405 clear. Also here we see a huge market. We have a lot of requests. This material is also really outperforming on elongation at break. This material has an elongation at break of around 130% and can be used also for visible parts and every application which you can imagine where it has to be a clear material, transparent material. We really can say this is a perfect fit to Asiga. Asiga also has a special solution with clear material. Maybe we can talk about that in some of the next months. I really believe there's a lot of potential. And of course, our elastomer technology, which are used mainly for every kind of lattice structure. As I was currently working for powder bed fusion technologies, typically with materials like TPU, you have all the powder and the dust, and you know how to bring away the dust and the powder away from the lattice structure. This is really a perfect fit for DLP. DLP is very fast, can produce this very nice lattice structure. And today, if you look, I know companies are mostly using, I would say, DLP for that kind of application because it's really a perfect fit. You can just out of the print use the part. And on the other side, as Hendrik mentioned, we are very humble that also during the Corona crisis, we produced the nozzle swap. And today we have a huge market segment with hearing aids. We see a lot of potential also there for a company who might want to enter this. I think it's also has a very bright future. Another slide, which I just want to give you, it's a very quick and dirty overview about the industries. Also to give an idea that we are really far off from just being a prototype, just being a very maybe not relying resin that really changed in the last year. So really all you can see here, it's something which was created in I would say roughly 1 year or maybe a bit more. But we are really entering in B2B segments. We have for some of our resins the flame, smoke and toxicity standard achieved from Airbus. We have also the toxic gas pass from Boeing. We have the UN 94 achieved V0, which is the most challenging for the UN certification. We have passed it with 3 millimeters. We have some material fitting for the European railways, where we have passed different types of the EN 45545 norm. And for the automotive, we see a big traction really here. If you have customer in the automotive, please reach also us out, reach Asiga. We see there a lot of material fitting into the portfolio. I will also share in a shortly a case study which we created around that. And also we have first materials being IMDS registered, which is very important. If you are going to supply serial application part to automotive, it will be registered into IMDS. And also here we have started with a lot of nice first serial application project. And the other thing is the medical, of course, as already Hendrik told you, there are different full biocompetitive material which we can offer. Hendrik, it's your turn.
Yeah. So just real quick, to give you guys an overview, we talked about validation, and this is an overview about what already has been validated on the Asiga machines, what is currently in process. So the yellow dots are the in-process logos, and the green dots are which are already validated. So you see that a lot of very popular resins are already validated. So, and I'm always really impressed by the Asigas because they're, let's say, compared to other printers, they're cheap, but that doesn't mean that like your quality or your parts come out of Asiga printers are cheap or less in qualities. They're really great. Really love to print with the Asigas, and it's just to highlight that you guys can really start with printing these materials. And as you may see, the 3955, because this is kind of a hidden secrecy, it's not very well known that we validated the 3955 on the Asiga. The Asiga managed to have a homogeneous 60C, making the material able to print and look as it should be. And this is very good. This is very impressive. So next slide, please.
Yeah, maybe just a comment from my side. So
Sure.
thanks to Albert, the software, thanks to the workflow validation process, which Henrik also mentioned, this is just a short instant picture. So whenever you as a Asiga user or as a potential reseller, whatever, are interested in one of those material, we can go to this workflow validation process together with Corey, Asiga, and Henrik. Together with our software Albert, we can really quick implement new processes. So please reach us out whenever you have material which might not be already qualified yet.
Yes. So validation is good. Controlling everything is better, but what is really missing? Also, these questions are coming over and over again from like big OEMs, because they need certification, they need clarity how material behaves over time. So what is about the durability? And this is really our focus from our technical department, to create data on durability, because we know, sure, these materials are UV sensitive, UV reactive. There will be something happen over time with UV exposure. Also, like heat is a thing, because like it's accelerating the aging process. Also, what is about chemical resistancy? So those questions are coming over and over again. And this is why our task for this year is to create also for the next years, whenever, like as many materials we have, or the more material we have, the more data we will surely create. And just for an example, because like our 3843 is our most sold product, we already created these data. Yeah, please start with the top. Because I want to take this as an example, and this is also like our TDS. We don't just want to have like a 2-page paper where just static values are highlighted. Like, sure, we are still doing this. We're still highlighting our mechanical properties, our thermal properties with static values. But we decided to extend these technical data sheets to a point where we also have like all the durability data included. I mean, we know that OEMs or big customers, they will still test it on their own, but it gives them a really good indication about the material and a feeling which material could maybe fit into their applications. So yeah, now scroll a little bit down, please. So sure, we have all the static behaviors here, and now we're coming to these pages. We create these pages in terms of durability. So we inserted the diagrams, how the material behaves. For example, here the aging, the thermal aging at 22 C, how it behaves after 1,000 hours, how it behaves after 1,000 hours at 50 C, at 75 C. Because this is what a customer really wants to know. Scroll down a bit. Yeah, next one, like QSA and UV exposuring, also here exposed to 100 hours. How are the mechanical properties looking after those 100 hours, after those 500 or 1,000 hours? And all these data we are creating on our sites in Concord, in Heidelberg, and so on, with different equipment. We invested a lot of money in testing equipment, and yeah, we want to really highlight that on our technical data sheets and make you be able to find the perfect material for your applications. All right. Now, I would just want to give a short introduction to our newest member of the Loctite material family, because it's a special one and it's a unique one, the 3D IND 380. It was just announced a couple of weeks ago. It's an ESD safe material, so with great static dissipative properties. It's a material for fixtures for tooling at high temperature, like molding, low pressure, but especially for the electronic device manufacturing processes established at several customer sites. And this is really, it's a high modulus, means very stiff material with really good HDT, super accuracy, like high accuracy and fine detailed printing, and a real good surface finish. Just as a kind of a teaser. Yeah.
Thanks, Hendrik. Yeah. So this is one of the newest. Will be, I think, is currently the pre-launch phase. We're going in the next couple of months. You will hear more about that. I really like to give you some, let's say, two case study, just to give an idea what have been achieved, especially in the last months. It was really also the possibility for us to publish some of our cases, because we are currently a lot of projects ongoing. Unfortunately, most of those cannot be reshared, but we have two main companies which also allowed us to share this case. And we were really proud and give you like also guidance for you as an Asiga user or potential Asiga user, what can we do with an Asiga machine, for example, using one of our material. The first thing, which we also announced a couple of weeks ago on LinkedIn, maybe you followed it already, but I really get not bored to share it, because it's just 1 month old case study, is a real serial application with KTM, which we created on a 3843 material, which perfect functions also on Asiga machine. This was one of my first project when I switched and changed to Henkel around 1 year ago. We really tried to find serial application parts and really challenge our material and see if it is passing the test which is required. And this was, for example, also UV. It was temperature. It was accelerated weathering test. It was a chemical resistant test against motor oil, against salt in the winter when it's snowing. We could finally approve all the tests. It was approved by the TÜV. We have registered it IMDS on the IMDS database, and we have today really a serial application which is running, which is the piece which you can hear on the Duke 390 together with VP, which is like a tuning company, upgrade company from KTM. So if today you're going to buy a Duke 390 and you're asking for the VP upgrade package, this is really part of of our resin. This makes us, I think this allows all of you to enter into automotive companies, because also we have set up a very quick process to really implement IMDS parts. So whenever you have a company who's really talking serious about serial application on automotive, we can also manage as a material supplier to make the material available on the IMDS database. The other thing which is very nice, also just a couple of weeks ago, so both cases very fresh, is the tooling which we mentioned before. For example, the IND 147 has an HDT of 290 degrees, which perfect fits for a lot of application, which can be used as a tool insert. Also here, Pepsi created, I think it was patented already in 2020, so we could not talk about that before, but they patented already 2020, and they created like a hybrid tooling solution where they use for the outer part metal, and for the inner part they use today our IND 147 tooling material. So also here, when I showed you before the general overview, keep in mind we have some very strong tooling material. You might also heard about the Echo case, where you're doing like shoe molds, last molds. We have also experience with LSR, silicon injections. So really you can reach us out, and I think together with our technical team like Hendrik and worldwide, we can support also specific. Why I'm saying this is because we also learned that tooling, because of the pressure, because of the temperature, because also of the material which you're using as injection, might need to have a custom solution to be created. Albert also allows us, the software, to be very quick in developing new materials. So for the tooling also, if you have a very nice future and nice new application, you can also reach us out and we can find a solution for you. Last but not least, I also want to give you an overview of our website, because you can really find everything. I'm using this as a sales and business developer daily, because it's really intended to have like all information collected on one website. For example, we have the printer and post-processing set up where you can, for example, select your Asiga machine with a validated workflow which we created along with them, and you will find like the properties which you need and you can create on your machine, like the build styles which need to be entered in order to make this successful on your machine. And this is actually the workflow validation process. The result, it's not only the file itself, the INI file for the Asiga machine, but of course also the printer setting and how we achieve the properties which we show on our data sheet. The other thing which is very interesting is of course our general material brochure. It's also visible on our website. Why I'm showing this? Because it gives everything at a glance, a very good overview. XY axis, for example, typically in B2B, you will talk about temperature. Typically, we talk also about elongation at break, for example. We created some nice overviews where you have a really immediately a good overview about which material achieve which kind of properties on those two axes. Is it a more high temperature material? Is it more a high elongation material? Or do you need something which has like an balance, which could be, for example, the IND406, which is a material which automotive company likes very much because it has an HDT of over 100 degrees, but still elongation of 25-30%. The other thing is our elastomer materials. As you might know, if you are working B2B, typically question are which kind of shore hardness does the material have? We have like 60 to 80, 90. This is like our portfolio. And we have from prototyping material to also more functional serial application material, because we have a material which has a higher tear strength. So we are trying to measure it with tear strength, but also very open. If you have other projects to measure in other ways, I just wanted to give you this guidance, because those two pictures plus also page 4 gives you really a full overview about the materials and the properties in one pager, and it's very, very easy to look into it. Last but not least, I also show you the case study, which was 2, but also we have more of that. So feel free to go on our website, which is Loctite AM for additive manufacturing.com. You will also find some other stories. And you know, we are talking about case studies. It seems like a study, but these are really serial applications. So really Pepsi is using this for tooling, KTM is printing this for serial application, and you can also find other like connectors and circuit boards. And may finalize the point is that if you want to have a quick overview about the data sheet, about safety data sheet, which really often comes up, of course you can reach us out. But the other thing is we have created a site called Data Sheets, where you have all the data sheets with all the data which also Hendrik showed, which is electrical properties, mechanical properties. How does it behave with water? How does it behave with chemical? How does it behave on long term? How does it behave on UV? We really try to collect all the information for all of the data sheet. Plus you will also find a link to the safety data sheet overview. Yeah, saying that, we really like to thank you. I think we're on good on time for Q&A. Also, please reach us out. I will manage them with the technical team like Hendrik. So if you have any question, you can also directly try or reach me out, and we will guide you through our organization or with a technical team like Hendrik.
Awesome. Well, thank you so much, Vittorio and Hendrik. That was amazing to see all the latest and greatest from Henkel Loctite. Before we go into Q&A, I do want to share my screen again real quick and just cover the product line from Asiga so you guys can see what type of printers we have and see if there's a fit, and talk about our latest machine, the Asiga Pro 4K XL. And so let me give this a share. All right, so everybody should be able to see my screen. And let me do something real quick. Okay, there we go. That's good. All right. And so this last July, or not July, actually, it was last May at Rapid TCT, we had a new machine that was launched. And so I'm sure you all are familiar with our current or previous product line, which is our Max, our Max X, and then our Pro 4K. But then we found there's a need for the Pro 4K XL, a taller, bigger brother to the 4K. And so how the 4KXL kind of came to be is we had a reseller that came to us with a customer that had a problem and said, hey, we need a taller printer. We need to print taller parts or longer parts. And so our engineers got together and were like, you know what? Let's go ahead and let's build the 4KXL. And so that's kind of how the 4KXL was born. And we launched it at Rapid TCT this last year. And it's a phenomenal machine. Just to show a quick video highlight of it, let me pull that up. This was kind of like a teaser video we launched.
We cannot see the video.
Sorry about that. You couldn't see the video. Let me share that again. It should be able to. How about now? Can you see the video? All right. Sorry about that. At least you got to hear the catchy video or the sound or music, hopefully.
The sound was
The sound was good. All right. Here we go. Excellent. So just a quick note, can you guys see the slide again now after the video? Perfect. So I always find it funny when we have technological companies such as like Henkel or Asiga, and we run these presentations and then we stumble upon like the most simplest technical difficulties with an application called Zoom that we use so often. And so sorry about the little glitch there. So that's our Asiga Pro 4KXL. It's a very exciting machine for us because we wanted something that can print larger parts. And so our new machine, the 4KXL, it is the exact same build envelope size as the 4K offerings that we have, but it has a 400 millimeter Z-axis. And so if you were at Rapid TCT, you're able to see some of the parts that were printed on the dirt bike that we had on display. So for example, like the fork covers. And then also you can see there's a swing arm on the right-hand side, just showing a large-scale production part. And if we look at the technical features of the 4KXL, it has the exact same advancements that our other equipment has. It has the SPS, that smart positioning system technology. You can get it in a 405 nanometer light technology or 385, the UV light technology. That has that same excellent pixel placement, very small pixels itself, and it has the high speed of printing up to 60 millimeters per hour. And of course, it comes with that very economical cost from Asiga at $29,990. Buying a printer at this scale, this size, we are going to be the most affordable option and probably one of the best printers available for that. I do have a print that actually came off of that we had on display. Just so you guys can see just the sheer size. I mean, this thing it's massive. And so this was printed on that 4KXL. And I believe this was the 3843 material, Victoria, that we were discussing earlier. And so it's just really resilient, very strong. And you can just see the sheer mass that we can actually print on the Pro 4KXL today. So when we look at the key industries that this printer fits in, looking at medical, transportation, automotive, aerospace, defense, architecture, general industrial applications where you need to print those longer or larger scale parts, and ultimately, what will it unlock next? And when we look at Asiga, we're known for being open on the material science side. And so that's where partnerships such as Henkel Loctite and Asiga just grow so well together because they have materials for those open platform systems such as Asiga. Plus, if there's anything outside of Henkel that you need to find, we have over 500 validated profiles available. All right, that was the only sales plug I had for the whole presentation, but it's so users and so the attendees could see our latest printer. Let's go ahead and let's jump into Q&A. We had quite a few questions come up, guys. I'm just going to go ahead and exit out of the presentation. So the first questions I think we had come in was actually for Henkel, and it says, is Henkel already working on a TPO shell or free shell material due to the fact that there will be a shift of TPO materials in reprotoxic class?
Yes, I can answer on this. We know that fact. That's a good point, and yeah, we are working to like reformulate without TPO all of our current healthcare materials, and all of our new materials coming up to the market are already TPO free. We know that it is on the focus of REACH. We know that those are called like reprotoxic class, and yeah, all of them will be available TPO free in the future.
Good, awesome. Awesome. We had another one come in regarding the TPO, so that's answered there. And then this is also for Hendrik. The UL94V-O certification right now only applies to the 3995 and the Industrial 404 when printed on the Stratasys Origin 1 printer. Is the intention to add the Asiga printer to this recognition in the future?
This depends. As we said, the results from a subjective point is already on the quality level are on the same level. We are really happy with the Asiga machines here. It's not included on the blue card because it costs a lot of money, and this is also why we're doing this webinar. We really want to make people having more having like heads up attention to the Asiga machines, because they deserve a lot more attention. They're able to do really good results, high quality, and once we got like more and more requests about this, we will do or think about it. Yeah.
Cool. Awesome.
I can also comment on that. So I think important is that we can prove, as I think the comment was, that it's already approved on one printer OEM. So yes, I think we have achieved that it's feasible. As Hendrik mentioned, if you also calculate internal labor costs, you come up at, I would say, a higher 5-digit investment to have it listed UL94. And also we are in discussion because UL94 is asking for every kind of different build style setup, wall thickness, layer thickness, an extra UL certification, which costs of course a lot of money. I think generally a lot of companies currently 3D printing are also trying to create an awareness that maybe a general approval by a build style can be used for different other one.
Very good. And then regarding the 3955, this material looks very useful for high temp applications. As far as I know, it requires 60 C during printing. Not sure Asiga or other DLP machines are capable for such a heat environment during the print process. Do you have any plans to reformulate the material to require lower temperature while printing, but still have above the 200 C HDT? I can touch real quick on the printer side, and then I'll let you guys answer the material side. And so for our materials, we recommend using a heating system to heat up the resin itself before using it in the machine, and then also preheating the build plate. And so we found that if you preheat the build plate up to about 80 C, and then when you go to start to print with the internal heating chamber on the printer itself, it actually still maintains the proper viscosity and is able to print successfully. And so I just printed a few parts for a customer on the 3955 as a sample on an Asiga Max, and I was able to achieve, it was close to about 40 degrees Celsius inside of the print chamber. The print job took it was almost 3 hours long, and the material viscosity did not change throughout that time. And I did use a preheated build plate. And so that was very successful with it, and the parts looked phenomenal. And so I think the only thing that would really cause an issue is if you had something that took a very long time. And when I say very long, I mean you're talking probably upwards to 8 to 10 hours where you may encounter any sort of issue with any printer with that type of material perhaps. But that would be a really long print job. It's rare that you would ever encounter that. Victoria and Hendrik, I'll let you guys answer from the material side. What are you guys working on that may fit into that scope that doesn't need to be heated itself?
Yeah. So yeah, the material and its chemistry is really unique. And there is currently no plan to do a reformulation or something else which then results in requirements to not having that 60C. This is currently not in the focus because it is. I'm not a chemist, so I can't go into detail. But it's really it's not in the focus. What I've heard from the development side is that it's also not possible. It is so special with that ULB 0, and there are special properties due to the fact that it is a solid state at room temperature and liquid at 60C. So there will be no reformulation.
Gotcha. Cool. Thanks for that. Another question came through. Can we get this a copy of the PowerPoint after the presentation? I think that would be okay. What we'll do after the presentation, we can send it to all the attendees. And then we had a question come through about, this is for us at Asiga. Are the printers listed in accordance to the nationally recognized test laboratory? And then they said based upon their lookup, they should fall under the EN IEC UL CSA 62368-1. So currently we are going through testing itself. And so if you have anything specific for any special requirements that is necessary for your facility for really any sort of certification, please email us at info@asiga.com. If we don't have that certification already, then we can go ahead and take a look at it further and how it applies and what is necessary for your workflow. Absolutely. And then a couple comments about not being able to see the video. Sorry about that, guys. And then we had, what is the difference between the INI file from a 4K and 4K XL? There's actually no difference. The machines are actually identical and print the same. The only difference is the vertical height on the 4K XL. And so all materials that are validated on the 4K, they're going to perform the same on the 4K XL. Loctite is going through and will go through and perform the extra validation necessary to make sure of that, but I know from our testing that it's not going to make a difference. Let's see here, we have 2 more questions in the chat, and then we have a series of questions in the Q&A box as well. Are you guys, when I say are you guys, Loctite team, are you guys certifying other cure and wash systems for your post-processing?
Yeah, we're not only using our CL36, the Uvalog, especially in the medical section. It's very common to use, for example, a driven PCU LED or auto flash. So we do validations with these post-processing devices as well. We have them on site. So actually we are trying to use whatever is very common in the market. If there's a special need to get a validation done with in a specific configuration, including a specific post-curing device, we will do so if we're having it on site. Yeah.
Awesome. And then let's jump into the rest of the Q&A. And so
I think there was just another question when they will be launched, the TPO-free resins.
TPO-free, yeah.
Oh, shoot. Yeah, sorry.
It's I can say it's on a let's say beta state, so Q3 to Q4, so this year they will be launched. Yeah.
Awesome. And this came through earlier in the presentation. It says, do any of the elastomeric DLP resins promise long service lives for parts used on the exterior of road vehicles, subject to extreme temperatures as well as solar and UV, like radiation, etc.?
Yeah, this is ongoing. This is really at the moment ongoing. There are parts placed in our testing machines for elastic materials. we will have more data which will be then published on our technical data sheets later this year, like also Q3 to Q4, because like these extended tests, they need time, say for over 1,000 hours, and so this is why I can't give here a qualitative statement on this question if they withstand. And it's also depending on what are the requirements, like sure, they will change in their properties, but what is still acceptable? Is it are you looking for like a withstancy in a specific standard, like, but we can talk about this later for sure. You can contact Vittorio if you have special special questions about those topics, and we can chat about that later. Yeah.
Awesome. The next series of questions we came through looks like it's, do you have any foam-like photopolymers? And so we see a lot of, quite a few lattice-like structures where people are printing, kind of trying to like replicate foam applications. Mm-hmm. Are you guys working on a like expandable foam type application in the future?
No. We really go with the approach to kind of pretend being a foam material with creating smart lattice structures. I think this is really also the advantage of 3D printing and the DLP technology. So we're not planning to create a foam-like photopolymer.
Okay. And then we have two last questions, I think, at this point in time. The second last one is, where can we find which materials are compatible to 4K, Asiga 4K, and how do you switch materials? So I can answer both of those. So for finding materials that's compatible with the Asiga line of 3D printers, you can either find it from Henkel Loctite's website. They have that configurator that allows you to choose your the material you want, or the printer you want, material, and etc. Also, you can find that on your Asiga account. And so if you are an existing Asiga user, if you go to asiga.com and log into your account, under the materials tab, there is an area that shows all the available profiles available. And then switching materials is actually quite simple. You would simply just have another tray, and you would unlock one tray for one material and put in the new tray back into the printer. There's no calibration necessary. It's actually very easy. And then the final question is there a cost to use other materials on the Asiga profile? And there's actually not. So we do not charge for any materials in any way, shape, or form. You can use any material you want in your Asiga 3D printer, and that's the beautiful thing about partnering with an open material system, is that we give you the complete freedom, no monthly fees, no annual fees, no charges whatsoever. I think everything is answered. Before we conclude, I just want to thank you both, Vittorio and Hendrik, for taking time out of your afternoon and your morning for these presentation. It was excellent having you guys on, and thank you to all of the attendees for joining in on this discussion. A lot of very fruitful questions, and we look forward to helping everybody out in the future. Once again, if you need any sort of information, please feel free to reach out to Vittorio or Hendrik, or if you need information from Asiga, you can always go to our website or email us directly at info@asiga.com.
Thank you very much,
Awesome.
Corey, and the audience.
Thank you very much for having us.
Yeah.
Pleasure.
Thanks, guys. Take care.
Yeah, you
Ciao,
too.
ciao.
See you.